In this video, I'm going to go over a number of examples where I add and subtract fractions that have unlike denominators. Here's the procedure. You need to find the LCD, and there's a video up on how to do that. You need to use the multiplicative identity to build equivalent fractions. There's a video up on that. And then you just add and subtract the numerators and keep the common denominator, because since the denominators are now common, you're counting units of the same size. And then if you can reduce at the end, you do reduce at the end. And there's videos up on that, how we reduce using prime factorizations. Here's the first example. Step 1, we have to find an LCD. Here's the prime factorizations, and the LCD is 12. Next, we need to return to our original fractions and multiply them by 1 so we do not change their value. And the form of one I take has to be the one which brings my original denominator to the LCD. For my first fraction, I'll need 2 over 2. For my second fraction, I'll need 3 over 3. And for my third fraction, I'll need the form of 1, 4 over 4. And again, the reason for that is I needed to take a denominator of 6 to a denominator of 12. I needed to take the 4 to a 12 and the 3 to a 12. And so all my denominators will now be a 12. Of course, I'll need to multiply the numerators also. 2 times 1 is 2, 3 times 5 is 15, 4 times 2 is 8. Those are my new numerators. I'm now counting units of size 1/12. I start with 2, I pick up 15 more, I'm up to 17. I lose 8, I'm down to 9 units of 1/12. And we can then reduce common factors of 1. Notice again, this is the multiplicative identity from the other point of view. That is, 1 times 3/4 is 3/4. So I take out my factor of 1 and I'm left with 3/4. Here's the next one. First, I'll need to find the LCD, and that's 36. I return to my original fractions, and the form of 1 I want for the first is 3 over 3, and for the second, 2 over 2. Multiplying numerators and denominators together, I'll get 21/36 and 10/36. And then I have a common denominator, and I can subtract and get 11/36. Here's the next one. Here's the LCD. My forms of 1 will be 8 over 8, 5 over 5, and 4 over 4. In each case, that will bring my denominator to a 40. My first fraction will be 32 over 40, my second 15 over 40, and my third 12 over 40. Subtracting gives me 5 over 40. So you can reduce common factors and end up with 1/8. Try this one. Here the LCD is 84. My factors of 1 will be 14 over 14, 6 over 6, and 7 over 7. Now again, if you can't look at it and see it, take 84, divide it by 6, and that'll give you 14. Personally, here's what I do. If this doesn't make sense, don't worry about it. Just use your calculator. I return to my LCD. I need to know, what do you multiply to 6 to get an 84? Well, it must be a 14, because 6 and 14 is 84. And if I have a 14, I must need a 6. And if I have a 12, 2 2s and a 3, I must need a 7. So I don't use a calculator. Once I have the LCD, I just use that. After multiplying numerators and denominators, here are my equivalent fractions. I go through and subtract and add left to right. Now notice 1 plus 1 plus 7 is 9. 8 plus 4 is 12. There's a factor of 3 in both, which I can take out, and here's my final fraction. Here's another one. You should always start by making improper fractions from mixed numbers. Here's the LCD. Here are my factors of 1. Here are my equivalent fractions. I add in the numerators, and if we start with mixed numbers, we usually end with mixed numbers. Either answer is equivalent. It's just, like I say, the tradition is, if you're going to start with mixed numbers, end with them. And here's the last one. First, I would write the mixed number as an improper fraction. Then find the LCD. Return to the originals and multiply by 1. That builds my equivalent fractions. And then I add and subtract left to right. I don't see any common factors, but I did start with a mixed number, so you may want to end with a mixed number. It's up to you. Well, that concludes our work with adding and subtracting fractions with unlike denominators.